So today we're going to talk about polynomial functions and discuss their end behavior on a graph. So we should all know what y equals x squared looks like. That's a regular parabola. That's the parent graph of all parabolas, right? And we should all know what a graph really is. A graph really represents every single answer that exists to the equation. So any coordinate, 0, 0, that's an answer to this. A 0 squared will give you a 0. 1, 1. If you 1 squared will give you a 1. So any point on this parabola is actually a solution to this quadratic equation. And again, we should all know what y equals x squared looks like. We actually have that famous pattern from this parent graph, the 1, 1, 2, 4, 3, 9 that we always use on parabolas. That's from this parent graph. What if I put a negative sign right in front of the x? What would happen? It gets reflected over the x-axis. So same parabola, it's just opening down instead of up, right? And we should all know that if you take your function and put a negative in front of it, it's going to cause it to reflect over the x-axis. All right. Anyway, let's go back and discuss what y equals x to the third looks like. Now, we already graphed it on Desmos. We already saw it. But let's really understand what it is. It's really an input-output table. You're going to list your solutions. So if I were to plug in 0 right in there, what's 0 to the third power? 0. What is 1? If I take the 1, plug it in there, what's 1 to the third power? 1. How about 2? If I plug in 2 right in there, what's 2 to the third power? 8. All right, great. How about negative 1? If I plug in negative 1 right in there, what's negative 1 in parentheses to the third power?
1.
It's negative 1, right? What if I plug in negative 2? You get negative 8. Now let's see what that looks like. 0, 0 is right here. 1, 1 is right here. Now 2, 8, 1, 2, 8 goes all the way up here to the edge. This is an 8 by 8 graph. And the negative 1, negative 1, negative 1, negative 1 would be right here. And negative 2, negative 8 would be down here. So what I have is this snake-like curve, right? Okay, now let's discuss end behavior. That's one of the important topics of today, end behavior. Now, what do I mean by end behavior? Like, yeah, there could be some funkiness going on right here, but where does it end up? Where does it end up? If you look to the right, where does it end up? Up here, right? If you look to the left, where does it end up? Down here in quadrant 3. You guys remember quadrants, right? Quadrant 1, 2, 3, 4. It's just going counterclockwise. 1, 2, 3, 4. So if I said describe where this graph ends up as you look at it to the left, where does it end up? It ends up down here, right? Now we need to explain this using the correct math notation. So ladies and gentlemen, instead of saying as I go to the left, this is what we're going to write. As x approaches negative infinity. Okay? That's saying as I look to the left. Right? Here's your x-axis. Here's 1, 2, 3, 4, 5, 6, 7, 8 on the x-axis. You keep going to positive infinity. But here over here is negative 1, negative 2, negative 3, negative 4, negative 5, all the way to negative infinity. So when I say as x approaches, the arrow means approaches. As x approaches negative infinity, that's really saying as you look to the left, then f of x, the actual graph of this function, f of x, goes to negative infinity. As you go to the left, remember f of x is the same thing as y. Y goes to negative infinity. Y goes down. Does that make sense? This is just saying as you look at it from the center to the left. Now let's look at it in the other direction. Then you would say, and as x approaches positive infinity, that means going that way, what's happening to this function? Where is it going? Is it going to positive infinity or negative infinity if you go to the right? Positive infinity. So as you go to the right, as x approaches positive infinity, as you go to the right, we're going to say f of x goes to positive infinity. Does that make sense? Okay, how about this? Let's go to our notebooks and sketch your parent graph parabola. You could do any sketch. Just do a XY plane. Doesn't have to be perfect. just go ahead and put your vertex at 0, 0, and draw this U-shaped curve right there. Who cares? Who cares about, we just want to sketch, all right? And what I would like you to do is let's describe the end behavior of this parabola. Let's describe the end behavior of this parabola. So ladies and gentlemen, let's write this down. So let's describe the end behavior of this parent graph. Okay, so everybody write this down, please. As x approaches, let's start with negative infinity. And what do I mean by starting with negative infinity? We're really saying as you look at this graph going to the left, as you look at this graph going to the left, what's happening to your y values? Are your y values increasing or are they decreasing as you go to the left? They're what? They're increasing. So as x approaches negative infinity, as you look at it to the left, we're going to put comma f of x, which means y approaches what? Approaches positive infinity. That's one statement right there. And let's also say, and as x approaches what? Positive infinity. Now, what does that really mean as x approaches positive infinity? That's saying as you look at it to the right, what's happening to this graph as you look at it to the right? Is it getting bigger on the y's or is it getting smaller, more negative on the y's? It's getting bigger. So what do I say? As x approaches positive infinity, my y values, but I'm calling them f of x. F of x is the same thing as y. My f of x values what? Approach what? Positive infinity. Nice and easy, right? Okay, do another sketch. Do this one. It's really easy. It's the same parent graph, but it's negative. Negative x squared. Y equals negative x squared. Just, again, forget about coordinates. Forget about being precise. Just do an x-axis, do a y-axis, put the point right there at the origin, draw your U-shaped curve like that. And let's describe the end behavior on this guy. Okay? So I always like, now you could describe it any way you want, and as a matter of fact, the worksheet describes it a little different. I always like to talk about x values first, and I always like to look at the left side first. All right? So let's write this down. As x approaches, I want to go to the left, so approaches what? Negative infinity, comma, f of x, your y values approach what? Negative infinity. Perfect. So as you go to the left, it's going down to negative infinity. Now we're going to state the other one. And as x approaches, how about to the right? How do I say that? How do I say that? As x approaches positive infinity, f of x approaches what? Negative infinity. Some of us got it. Some of us are like thinking, what the heck is going on, right? This first part, as x approaches negative infinity, that's just saying as you go to the left. Here's x, 1, 2, 3, 4. As x approaches negative infinity, negative 1, negative 2, negative 3, negative 4. That's saying as you go to the left, as x approaches negative infinity, that means as you go to the left, where are your y values at? Are they up here or are they down here? Oh, they're going down, right? As x is to the right, as x is going to positive infinity, where are your y values at? They're down here in the negative. Okay, so if we go to the y equals x to the third, we said as x approaches negative infinity, then your f of x functions also go down to negative infinity. As x approaches positive infinity, your f of x functions go up to positive infinity. Does that make sense now? Okay, now guess what would happen, ladies and gentlemen, if I put a negative sign right in front of this x cubed? What would happen? It would, what, okay, how about this? What happens, yeah, you said it. What was that? Reflects. Right here you have y equals x squared. Down here you have y equals negative x squared. It gets reflected over the x-axis. Maybe right now is a good time to do this. Okay. You got me? Yeah, it's working? It's working. Is it recording? It's recording. All right. So here's your y equals x squared. If I do y equals negative x squared, what happens? It's reflected over the x-axis, right? Okay. Here's your y equals x to the third. It's like a snake-like curve, right? It's down here in quadrant 3, up here in quadrant 1. Yes, make sense?
Yes.
And if I reflect it over the x-axis, what's going to happen? It's going to go like this, right? Yes? So you're right here, it reflected over the x-axis, it's going to go like that. All right, so that's what it's going to look like. Thank you. So let's go back over here to the y equals x cubed. The end behavior is up here in the first quadrant and down here on the third quadrant. So if I reflect it over the x-axis, this is going to go down, this is going to go up. Make sense? Yeah. So that's what it would look like if you reflect it over the x-axis. Okay. Now we did do the Desmos app right now, and we graphed odd degree functions and even degree functions. Let's flip this. And that takes us to this part of our notes right here. Take out your notes, and we're going to talk about odd degree functions and even degree functions. So on the upper right part of our notes, it says, if your polynomial function has an even degree, then the end behavior will be the same in the same direction. For example, y equals x squared, that's an even degree. Y equals x to the fourth, that's an even degree. Y equals x to the sixth, that's an even degree. All of those open up, all right? So I did take a picture of the Desmos app right here, and I did graph y equals x to the fourth. And if you look at the graph, it looks just like a parabola. And it's a little bit weirder. What do I mean by weirder? This middle part's a little weird. And it gets really weird if you change that x to the fourth, if you change it to like a standard form polynomial with degree 4, like plus x to the third, plus take away 2x squared plus 1x minus 5 or something like that. Look, I just threw in some stuff on this one. And it's going to have the same end behavior as a parabola because it's even. It's going to have the same end behavior, but with this other stuff in between, there's some funkiness that happens. Check it out. So you see, it still has the same end behavior. It still opens up. The end behavior is up here in quadrant 2 and up here in quadrant 1, but it's no longer just a regular U-shaped looking graph. It's now more like a W. Some weirdness happens in the middle, but that's okay. The end behavior is the same. That's what we're trying to cover today, what the end behavior looks like just by looking at the degree, by stating if it's odd or if it's even, okay? Y equals x to the third, we already graphed that. We already talked about that. Y equals x to the fifth. You see, it looks the same as y equals x to the third, but if you were to throw in other values like y equals x to the fifth, plus 2x to the fourth minus 3x to the third and other stuff like that, then it would just change the middle part, but the end behavior would still be up here and down here. Okay, so let's go back to our notes, and let's write down right here. For example, y equals x squared, y equals x to the fourth, y equals x to the sixth, all open up. So if you did just a quick sketch, they're all going to look like something like this. They all open up. And what truly matters is the end behavior right here and right here in quadrant 1 and quadrant 2. Now again, if you add on some more stuff like y equals x to the sixth plus 5x to the third minus 4x to the second plus 1x squared, take away, if you add some other stuff, other things are going to happen in between. But as long as your leading coefficient's positive and your degree is even, your end behavior will be in the first quadrant and the second quadrant. It'll be both up here opening up. Weirdness in the middle, but the end behavior will be the same. This next one, it says, likewise, if your leading coefficient's negative, all that means is that it's going to open down. So let's do a quick sketch of that right here in this area in our notes. This is going to open down. It doesn't matter if it's a power of 2, power of 4, power of 6. Both end behaviors are going to be going in the same direction. Okay? Yes, if you had other things like negative x to the fourth plus x to the third, take away x squared plus 1x. I don't know, if you had something else would happen in the middle, but the end behavior would still be the same. Are you with me? Yes? All right. Same thing with x to the third, x to the fifth. This should have been x to the seventh. Sorry, typo right there. X to the seventh. Those are all going to look like the end behavior like that. Some snake-like curve, right? But the end behavior is up here in quadrant 1 and down here in quadrant 3. Now it doesn't matter if you have x to the 7th. If you throw in other things like x to the 6th, x to the 5th, some weirdness happens in the middle, but you're still going to have the end behavior in quadrant 1 and quadrant 3. And if you put a negative, it just reflects it over to the other side. So let's actually put a negative and do a sketch of it being reflected to the other side. That would start up here, squiggly line right there. That'd be a snake-like curve looking like that. Please sketch those in your notes. And again, all we could be sure of is the end behavior. And remember, if they're asking you to find real zeros when they give you a graph, they're simply asking for the real answers, the real solutions, which are the x-intercepts. Okay? So if you have this graphing Desmos app, you could take any polynomial function, graph it, and see where it crosses the x-axis, and that'll be the solution. All right, so let's take a look at our first part of our homework. It's straight from the book. We're going to be doing these 6 questions, question 35 through 40 on page 327. You don't actually have to get the book. You could just copy them from the board right here, or you could hit pause on the video and copy them at home. And they want us to do 3 things with each of these graphs. They want you to describe the end behavior, and then also to determine whether it represents an odd function or an even degree function. Okay? And then state the number of real zeros. So let's do number 35 together. Everybody in your notebooks, you're going to have to, I don't have this printed out for you. You're going to have to copy this down in your notebooks. So let's do this. In our notebooks, let's write down homework. Homework, page 327. And we're doing numbers 35 through 40. That's going to be on your title of your page. Homework, page 327, numbers 35 through 40. And let's describe the 3 things that they want us to describe about this polynomial function. So the first thing, describe the end behavior. So let's all write down the end behavior together. Let's first look at it as it goes to the left. So as x approaches negative infinity, f of x approaches what? Positive infinity. As you look at it to the left, where's this going? It's going positive, up to the positive forever. So as x approaches negative infinity, f of x approaches positive infinity. And then we're going to say, and let's look at it to the right. So how are we going to say, looking at it to the right? As x approaches positive infinity, f of x approaches. So if I'm looking at it this way, where's the graph going? It's going positive, up. It's going up forever, so it's going to positive infinity. And ladies and gentlemen, this is what they want you to do for question A, or part A, to describe this exactly the way we just described it. Now, sometimes the books or the solutions on the worksheets, they give this backwards. They'll say, as f of x approaches positive infinity, x approaches negative infinity. You could write it any way you want, but I prefer writing the x's first. As x approaches negative infinity, what happens? Oh, it goes to positive infinity. As x approaches positive infinity, what happens to f of x? It approaches positive infinity as well. So let's use this note. Talk about x first and then f of x second. That's part A. Part B says determine whether it represents an odd degree function or an even degree function. So how the heck do I do that? That is based on the end behavior. It's really simple. All you got to do is wake up and pay attention right now. All right? Wake up, guys. The end behavior, where is it at? This one's pointing up, and this one's pointing up. So how many arrows do you have pointing up? 2. Is that an odd or an even number? Even. That's even. So this degree must be even. This function must have an even degree. So part B, this is an even degree function. It might be x to the 4th, it might be x to the 6th, it might be x to the 8th, y equals x to the 8th with some other stuff, right? Because other stuff happens in the middle. But I know that both of them are pointing up. I know it can't be y equals x squared, because y equals x squared will be a regular U-shaped curve, right? So it's at least y equals x to the 4th, x to the 6th, x to the 8th, x to the 10th, some even degree function. And the last thing that they ask for is state the number of real zeros. Now, that's one of the easiest questions they could ask you in Algebra 2 when they give you the graph. What are real zeros? Real solutions, real answers, real x-intercepts. So how many do I have?
4.
1, 2, 3, 4. So that's part C. It has 4 real zeros. Or you can say real answers, real solutions, real x-intercepts, whatever you want. But those are the 3 things that we're doing on each of these graphs in the homework on page, what is this, page 327. So 36, obviously, is this an odd degree function or an even degree function? It is odd. It only has 1 arrow pointing up. How many arrows does it have pointing down? Only 1, so that's an odd number. If it has both pointing up or both pointing down, that's an even degree function. If it has only 1 up or 1 down, that's an odd degree function, okay? So this whole thing is pretty easy. Go ahead and work through the rest of these. If you're doing this at home, hit pause so you could copy it down right now. In class, I'll keep this on the board. But right now, I also want to show you what I want you to do in addition to these 5 questions. I want you to do the last 3 questions of the worksheet from yesterday. So let's jump to those. Here's the worksheet from yesterday. By the way, if you didn't finish it, please finish it. But down here, it's the same exact thing that we were doing in the book. Same exact instructions. So describe their end behavior. So number 17, now on the back of the worksheet, they do it backwards. They say as f of x approaches positive infinity, you know, they say it backwards. I say write the x term first. All right, so let's write down as x approaches what? Negative infinity. That's saying as we look at it to the left, what's going to happen to f of x? F of x is going to go to positive infinity. Okay? And then we're also going to say and as x approaches, how do we say as it looks to the right? As you look to the right. As x approaches positive infinity, then f of x approaches where? Also positive infinity. That's the correct description of the end behavior of this. What kind of degree function is this? Is this an odd degree function or an even degree function? Even. How many arrows does it have pointing up? 2. Is that odd or even? The number 2, is it odd or even? It's even. So this has to be an even degree function. Is this one an odd degree function or an even degree function? Even, because it has 2 pointing up. Is this an odd degree function or an even degree function? Odd. It only has 1 pointing down and 1 pointing up, so that's odd. Okay, simple as that. Very easy stuff. So you need to determine the end behavior. You already described that. Part B is it odd or even? We said this one was even. That was part B. And state the number of real zeros. How many real answers do we have on this graph? 2, because it has 2 x-intercepts. Now, it might not even cross at all, or it might just touch once. But right here, you have 2 real answers, 2 real zeros. So part C would be 2 real solutions, or 2 real zeros, whatever you want to call it. You could even say 2 real roots, 2 real answers, 2 real x-intercepts. Now, if you do look at your answers in the back, they didn't do the description of the end behavior like this. I don't know why, but they did it a little bit different. Instead of talking about x's, it doesn't say as x approaches. They say the y values. They say the y value, as it goes up, the x also goes in the positive direction. So it's the same thing. It's just written a little backwards. All right, so don't get confused with these answers. Let's stick with talking about as x approaches to positive infinity or as x approaches to negative infinity, and then write the conclusion f of x will go either to positive or to negative infinity. So don't get confused with those answers. Just do the x's first and then talk about f of x's, which are the y's.